Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about giant movements of random variables. For multiple random variables case, giant movements of random variables. There are two types of giant movement of random variables that are giant movements about origin and second one is giant movement about mean. So now here in this video, I am going to discuss about giant movements about origin concept. In previous chapter, for single random variables, the giant movement about origin already discussed. So now here we are going to discuss about giant movements about origin for multiple random variables. So that are two random variables. The n plus kth order giant movement of two random variables, capital X and capital Y, is defined as, and it is denoted as n plus kth order giant movement of two random variables x and y is denoted as m suffix nk. So m suffix nk is equal expectation of x power n y power k is equal integral minus infinity to infinity integral minus infinity to infinity x power n into y power k fxy of x comma y dx dy. So this is the definition of n plus kth order giant movement about origin of two random variables x and y for continuous case. Where small n and small k are the positive integers. So substitute different values of n and different values of k. If k is equal to 0, then and what is the general representation of n plus kth order giant movement about origin m suffix nk. So now here in this representation, substitute k is equal to 0, then mn 0. So which is equal to expectation of x power n into y power 0. So y power 0 is 1, so expectation of x power n. So this expectation of x power n is the nth moment of random variable x. Nth moment of random variable x. So similarly, if small n is equal to 0, substitute small n is equal to 0 in this general representation, then m suffix 0k is equal to expectation of x power 0 into y power k. So x power 0 is 1, so which is equal to expectation of y power k. So expectation of y power k is the kth moment of random variable y. So that is the first order movements. In that n plus kth order general representation, substitute different values of n. The first order movements are m10 and m01 are the first order movements of the random variables x and y. That m10 and m01 are the expected values of the random variables x and y. So the first order movements are m10 n is equal to 1, k is equal to 0. That is the first order movement. So m10 is equal to expectation of x. So expectation of x is the first order movement of the random variable. So which is equal to, so now here in this equation, so expectation of x. So m10 is equal to expectation of x is equal integral minus infinity to infinity integral minus infinity to infinity x into fxy of x comma y dx dy. And one more first order movement is m01 is equal to, now here n is equal to 0, k is equal to 1. So which is equal to expectation of y. So which is equal to integral minus infinity to infinity integral minus infinity to infinity y into fxy of x comma y dx dy. So these two are the first order movements of the random variable. So the second order movements. So now here in this joint movement about origin, so there will be three number of second order joint movements. So that are M20, M02 and M11. There are three number of second order joint movements of the random variables x and y. So that second order movements are M20, M02 and M11. So M20. And what is the general representation? The general representation of the n plus kth order of the movement, general representation is m suffix nk, m suffix nk is the general representation, which is equal to expectation of x power n into y power k. So in this general representation, substitute n is equal to 2, k is equal to 0, we get m20, which is equal to expectation of x square. So m20 is the second order moment, expectation of x square, or m20 is the second order moment. So that m20 or expectation of x square is the mean square value of the random variable x. And next second order moment is m02. So in this equation substitute n is equal to 0 and k is equal to 2, we get m02, which is equal to expectation of y square. So m02 and expectation of y square is the second order moment of the random variable y, which is the mean square value of the random variable y. And one more second order moment is m11. In this expression, in this general order, general expression, substitute n is equal to 1, k is equal to 1, we get m11 moment, so which is equal to expectation of xy. So m11 or expectation of xy is called as the correlation between the random variables capital X and capital Y. Correlation between the random variables capital X and capital Y. And the correlation between the random variables x and y is denoted by r suffix xy. Correlation between the random variables is denoted by r suffix xy, and it is given by r suffix xy is equal to, or m11 is equal to, expectation of xy is equal to integral minus infinity to infinity, integral minus infinity to infinity, xy into fxy of x comma y dx dy. If correlation between two random variables, that is rxy is equal to 0, the random variables x and y are said to be orthogonal to each other. So the same concept can be applied to the n number of random variables. So that is n1 plus n2 plus and so on nth order movement of the random variables x1, x2, x3 and so on x suffix n is defined as expectation of, so previous we can define two random variables n plus kth order. What are the two random variables? Capital X and capital Y are the two random variables. The n plus kth order of the two random variables is given by or defined as, the definition is expectation of x power n into expectation of x power n into y power k is equal to double integral x power n y power k joint probability density function into dx dy. So now here similarly there are n number of random variables. That n number of random variables are x1, x2, x3 and so on x power n, and its order is n1 plus n2 plus n3 and so on n suffix nth order moment of the random variable definition for the continuous case is given by or defined as expectation of x1 power n1, x2 power n2, x3 power n3 and so on x suffix n power n suffix n is equal to integral minus infinity to infinity and so on integral minus infinity to infinity x1 power n1, x2 power n2 and so on xn power nn into giant probability density function of multiple random variables, that is fx1, x2 and so on xn of x1 comma x2 comma and so on xn into dx1, dx2 and so on dxn. So this is the concept of Joint movement about origin for multiple random variables.